Photons of light hit the retina of the eye. It is consisted of two things, which are called rods and cones. But we're going to look specifically at rods, which are known for seeing light. That's a light bulb. So a rod will look somewhat like this, and it has these little lines in it, which are called discs. So if we take this little portion of the rod and we explode it out, it'll look a little bit like this. It'll have these circular things, which are the discs, and then each disc will consist of little red dots. And these dots are called rhodopsin. And rhodopsin is made up of opsin and typically 11-cis retinol. Which are proteins that combined make rhodopsin. So I went ahead and I exploded this over here, and if you take this rhodopsin protein and you explode it, you'll get this kind of shape. About 7 rectangles, and then inside of it is what's called retinol, which is this calcium ion with this itty bitty squiggle after it. When a light photon hits the retinol, it causes the sodium-calcium-potassium gate pump to open, which allows sodium and potassium to run through, which causes the G protein to use GTP, the energizer, to bring protein kinase G and another protein kinase G together, which will cause the retinol to straighten out, which will look like this. Instead of curved like this, it'll look straight. Alright, transducing is what we learned is when the retinol will go from this curved shape to a straight shape. But not only does the retinol change, but so does the rhodopsin. So it'll go from this shape with your retinol on the inside to change to something like this. And this will be broken up into 3 subunits, and we'll just call them 1, 2, and 3. Once transduction occurs and the rhodopsin is broken up into 3 different parts, this first part will come off and attach to this disc and will be called phosphodiesterase, or PDE for short. And PDE activates something called cGMP, which will open the voltage-gated potassium ion channel, which is just attached to these on the side, which allows in all sorts of potassium ions. Once the sodium rushes in and causes depolarization, it will in turn cause hyperpolarization, which is when the voltage of the rod cell hits -70 millivolts. which will cause, in turn, these gates to close, not letting any more Na in. So, in turn, the rod cell will turn off, because a rod cell in its normal state before an action potential hits it is turned on. But when the rod cell is turned off, it sends a little signal to this thing called a bipolar cell. And when the rod cell is off, the bipolar cell is on, which will send a signal to the brain using a guanil cell, which tells the brain that there is light around. And that is phototransduction.